Okay, good morning again. So I'm going to be focusing today. I was asked to give a presentation on what we've learned on the effects of long-term application of repeated fires on understory vegetation communities in mixed oak forests. So really focusing today on the ground flora, but that's both the herbaceous and the woody species, and how fire affects species diversity and the structure of the understory. When we think about robust understory communities in the eastern United States, we think about when there's these communities that have high diversity and high cover of herbaceous species. We think of the longleaf pine savannas and woodlands in the southeast. Frequent fire is required. Other examples are in the Ozarks and Ouachitas, where we have shortleaf pine. This is a shortleaf pine restoration site with a robust herbaceous layer. It requires frequent fire. Same as this oak woodland in Missouri that's been burned over many years at Ha-Ha-Tonka State Park. And then just a couple other examples. In the upper Midwest, Wisconsin, there's these bur oak savannas. You can see there a very robust herbaceous layer. Another example is in Illinois, post oak flatwoods that John Taft has worked in Illinois. So in all these cases, it's really kind of a no-brainer in a way that these to maintain that herbaceous layer with the species that are there, you really need to have frequent fire, burning every 2, 3, 4 years in these systems. But in our closed canopy oak forests that we have in the Appalachians here, it's a little bit less clear. We do know that when fire is used properly on the right site and with some other silvicultural treatments, we can have really good oak and hickory regeneration. So the fire is a great tool for oak regeneration. But it's a little bit less clear how fire might affect that understory diversity. And that really, as far as plant diversity, that's really where its focus is, in that understory. Most of the species in the forest are in that understory layer. But in these closed canopy mixed oak forests, we have species, that's ferns here and wild geranium in the photograph that people don't really think of as being fire adapted. And then there's also concern that fire may harm some of the species in the understory. Okay, and that when you go out in oak stands today in a mature oak forest, that understory vegetation layer is really a function of several different things. Primarily, it's especially where we work, there's a lot of topographic variability, so you can really get much different communities from a dry southwest-facing slope than you do on a mesic north-facing slope. So it's really, and that's a sense of soil moisture and nutrients. It's also what's been the recent disturbance regime. Has there been any timber harvesting or canopy disturbances that are natural? What's the deer browsing pressure? All of that really affects that understory vegetation layer. And then there's also that long-term land use history. What was ever farmed in the past? What was the historic harvesting and grazing and fire? So there's really a lot of factors that go into really that site's potential to have a rich understory vegetation. Then there's another component to that understory vegetation, which is the potential vegetation that is lying dormant in the seed bank. And that really plays a role in when you start burning or start opening the canopy into what species get expressed from that seed bank when the soil is disturbed or the litter is burned off. And the seed banks vary a lot from site to site, and that depends on the history of the site, and also the site type. Is it a dry site or a mesic site? Just an example, in a mesic oak forest in North Carolina, Tara Kaiser in a study collected litter and soil, brought it back to the greenhouse, and germinated those seeds to see what was in the seed bank. And on average, there was almost 500 species 500 seeds that would germinate from a square meter of soil and litter. And it was pretty diverse. 133 species came up in that seed bank study, but that's not always the case. Sometimes seed banks can be depauperate. Okay, well, and we don't really know. I've always suspected that in these closed canopy oak forests that I work in, that probably the species that are sun-loving that need more light or have probably been declining over time, but we don't really know because 50 or 100 years ago, there weren't really people out doing quadrats in the woods. It wasn't, plant ecology was really not being done, but there is an exception to that. There's the vegetation of Wisconsin. John Curtis looked at a bunch of communities in Wisconsin and sampled the understory vegetation layer. So back in 1950, there was 94 upland oak stands that were revisited 50 years later. And what we found was these were undisturbed stands. There's been fire suppression, no management in these stands to speak of. And there's almost a 23% decline in species richness of the understory over that 50-year period. And most of that was native herbaceous species that declined. So I think that's happening in a lot of oak forests, but we don't really have the data to show it. So this was a study by Rogers that did show that. Okay, so what I'll be focusing on here, we've had a long-term study of thinning and or burning in southern Ohio, and I'm going to focus on the understory response, what we've seen over this 17-year period. Okay, we had 3 study sites in southern Ohio on Ohio Division of Forestry lands, and we had 4 treatments. They were about 200-acre sites that we established back in the year 2000. We had a control site where we just cut 1/3 of the basal area. This was a commercial harvest thinning, but it focused on the 6 to 10 or 12-inch stems to try to reduce basal area from below. So a lot of what was cut was red maple, but there was some overstories where trees were cut as well. And then we had repeated fire, and then the combination of those 2 treatments. And then this is the timeline. So we burned about every 4 or 5 years on a pretty regular schedule after that initial thin. And then we collected data periodically. Okay, so we had, on this study, we had a previous prescribed fire study in Ohio where we had just been starting out with prescribed fire. All the fires were very low intensity. We never punched any holes in the canopy. When we started this second study, Dan Yowsey, who was the principal investigator at the time, really told the Division of Forestry folks that, go ahead and, try to make these fires hotter this time. And they took that and ran with it. So we really did have a variety of fire intensities from low to high. And a lot of that was based on slope and aspect, but also the weather conditions that year. Okay. All right, the understory vegetation, I'm going to have a lot of graphs, not a lot of graphs, but a fair number of graphs here, and they all follow the same color scheme. The plots that have not been burned are blue and green, kind of cool colors, and then if it's been thinned and burned, the orange and the red colors are for the thin and burn or burn treatments. When we started this study, the understory diversity was not high, but basically it followed a moisture gradient. On the left axis there, the dry plots, south-facing slopes tended to be species poor, mostly woody plants, not many herbs. But as you go down to those north-facing slopes, you increase species diversity, and a lot of that was herbaceous species that you think of as woodland species. So that was before we started. There wasn't really much of a relationship with tree basal area. Tree basal area averaged about 120, so these were mature stands. There was variation, but there wasn't really a relationship between basal area and species richness. Okay, as far as the treatment effects on the overstory, you can see that on the burn and the thin and burn plots, by year 17, we basically the basal area had been reduced by about 1/3, and on those burn-only plots, the red lines there was a lot of variation. We had some complete canopy mortality, and then we had plots where there was no canopy mortality. But about a 1/3 of the basal area, by year 17, had been reduced. But stand density, you can see again, the burn and the thin and burn plots were very similar. We had about a 50% reduction in stand density of trees greater than 4 inches DBH. Just some visuals here, the differences in fire intensity. We have a low severity. We had a lot of areas that were low severity where the canopy was still intact, and then we had those areas where holes were blown in the canopy, and we had basically like small clear cuts where we had a lot of woody regeneration, and everything in between. Okay, this is species richness. So in a 1 meter squared quadrat, counting every species, woody and herbaceous, up to about 1 meter in height. And you can see that over time, the burn and the thin and burn plots clearly gained almost 100% in small-scale species richness, going from about 7 or 8 species per quadrat up to 13 to 14 species per quadrat. The thin-only plots, no response at all, really, and the controls stayed about the same. So it was really fire that stimulated the diversity. And when we look at the difference between, in that diversity, comparing herbaceous species and woody species, most of those gains in species richness were from herbaceous species. We did have a little bit of a bump in number of woody species, but most of that was herbaceous species. And looking at on the thin and burn plots and the burn plots, over that 17 years, 96 species were fairly common. They occurred in at least 20 or 30 quadrats out of all the quadrats we sampled. And you can see that the vast majority of those common species were increasers. They increased in frequency over time, or the number of quadrats occupied. There were 58 increasers, 29 species that didn't have much of a response, and only 10 species declined or had a significant decrease. The biggest decline there was red maple and then also red elm. Okay, this is for the botanists out there. Just a list of the top 15 increasers over time, and it was a real mixture of life forms too. Some of these species you think of as maybe there were woody species from the seed bank, rubus that a lot of you are familiar with that comes up after a burn. We had sumac, wild grape, things that were in the seed bank. We also had several panic grasses, dicantheliums, that came up out of the seed bank. And then there were some just forbs, various forbs. Some of them were dry site species, some of them were mesic site species. So it was just a real mixture of the biggest increasers across those life forms. But when we look at understory, the ground layer vegetation cover, those first slides that I showed you of those really robust herbaceous layers, what we found in this study with those burns every 4 or 5 years is we really developed more of a shrubby understory, where the herbaceous cover really maxed out at about 20% herbaceous cover. That was an increase, but it wasn't really that robust herbaceous layer. And the woody plant cover, the tree sprouts and the shrubs really dominated the structure of that understory. And you can see that here. Here in a photo, there's herbaceous plants mixed in there, but it's really dominated by the woody plants. I do have one slide of, and a lot of some of that was good woody plant regeneration, though. These are the 3 different study sites we had, and this is the large oak-hickory regeneration over time, greater than 2 feet tall. And you can see that at 2 of the sites, Zaleski and Vinton Furnace, these were drier sites that were more oaky. At least on 3 of the 4 treated units with fire, we really had a tremendous increase in the larger oak and hickory regeneration. But we also had a site, Tar Hollow, that was a little bit more productive and it had more invasive species. And with those same treatments, we really didn't get a response in oak regeneration. So there is a lot of difference. And of course, this also follows a moisture gradient. Most of that good oak regeneration was on the drier intermediate sites. The really mesic sites, oftentimes we didn't get much oak hickory regeneration pulse. Well, when we're surveying just every plot, 12 small quadrats, there's a lot of species you miss. So about halfway through the study, we wanted to kind of get a handle on maybe some of the more uncommon species that were there. So we did a complete walkthrough of each plot, which was 50 meters by 20 meters. And we would generally get about 60 to 90 species in a plot that size. But we were able to document some species that didn't necessarily show up in the quadrats frequently. Just as an example, these are 3 woodland goldenrod species that are kind of woodland indicators of an open forest. And looking at these 3 species kind of lumped together, the 4 treatments here, you can see that by year 8, this was after a couple fires, the red here is plots that they were present in and sort of a general abundance. You can see that on the burn and thin and burn plots, they were present in most of those plots by year 8. That's where they were pretty much absent still from the control and thin plots. So there were a lot of species like that maybe didn't look abundant in our small plot data, but they were there. They were there after the fires. Okay, so going back to that, before we started, dry plots were species poor. Mesic plots tended to have more richness of species. When we look at year 17, that sort of breaks down a little bit, and you can see the real, it's not as tight of a relationship, and the real difference is those burn plots have just really separated because they're more species rich. And also on that dry end of the gradient, there was really more increase relative to that median, to that mesic end. The mesic plots didn't decrease in diversity, they actually did increase too, but it just, that relationship kind of broke down. Fire was what was driving the diversity. Okay, the basal area. Remember, we didn't have much of a basal area response with herbaceous species when we started. By year 17, there was a stronger relationship, and you can see that. But again, it was really that fire, those drier plots that were species rich now, and that had lower basal diversity tended to be more rich. But again, it's really that separation there. On the top of the line are the burn plots, on the bottom of the line are the thin and control plots. So in most cases, in our study anyway, the thin and the burn treatments really were the same. I mean, because we had those higher intensity fires that over time, the thin and the burn were very similar. Okay, I did mention the non-native invasive plants. Two of our sites that were the more oaky sites, we had a little bit of stilt grass come in after the treatments, but the cover was not a lot. But at that one site where we didn't have very good oak regeneration, the more productive site, it had a little bit more agriculture history too, and it also had more invasive plants. You can see there was, especially on the thin and burn treatment, we had a lot of ailanthus and wineberry, which is a rubus, non-native rubus on that site. So again, there were significant site differences, but overall, on the drier oak sites, we really didn't have an invasive problem. Okay, just to compare our study with some other, few other long-term studies that have been done. There's another fire and fire surrogate study very similar to ours in Western North Carolina that Tom Waldrop and Helen Moore has been very involved in over the years. And looking at the Emily Oakman and Don Hagan just published a paper this year looking at the understory vegetation. They also did have a really good oak regeneration response on their site. But looking at the herbaceous layer cover on those thin and burn plots on both of our sites, they sort of got the same thing in North Carolina, where it was really that woody vegetation, the sprouts, that were dominating that understory. The herbaceous cover was maxed out at about 20%. So very similar between our two sites. There's a really long-term study in the Missouri oak woodlands that Ben Knapp reported on several years ago, where they had annual burning on smaller plots, so there wasn't high fire intensity, but for 60 years, or they had periodic burning every 4 years for 60 years, and Ben looked at the herbaceous diversity at the end of that period. So in the Missouri sites, you can see there was a big difference between the control and burn sites, and it had about 13 or 14 species per meter squared. But that was really similar to our 17-year study. We had a similar number of species on the thin and burn plots. Our controls were a little bit richer. But again, pretty similar results to our thin and burn higher intensity fires versus the long-term burning. I do want to, is Andy Vanderjacht still here today? Hey, Andy. Okay, thank you for sending these slides. And I was really impressed with some work that he's done. And you might have seen his poster, the Litter to Glitter is over there. But Andy was involved in the study in Tennessee where had been shortleaf pine stands that had been degraded by a southern pine beetle, and so they went in and really wanted to convert those with some heavy harvesting down to Woodland or Savanna state, and use fire to make oak woodlands or savannas out of those sites. And on that site, just with one fire, you can see the pictures there almost looked photoshopped, the before and after. It's kind of hard to believe that those closed canopy forests turned into what a really robust herbaceous response. So I just want to show that because it's really cool, but it's also, that really emphasizes that different sites have different potential for that herbaceous layer. And that, if you're trying to restore oak woodland, it's really key to get those sites that might have the potential to get that kind. We just didn't have some of those prairie type species in in our mix, even though we did increase diversity. So there's a lot of people to thank for this any long-term study. I really want to thank Ohio Division of Forestry for letting us conduct this research on their land and collaborating with us and doing all the prescribed burns and getting the thinning treatments done. And I just have a couple final thoughts, running a little bit low on time, but as far as in our study, we got, I'd say overall we had a really good oak regeneration response if it was the right site type. So in this case, it was compatible. We did get better oak regeneration, and we also got better herbaceous diversity. So I think those are compatible. But like on our sites, if the goal is more of a woodland restoration, where you have that really robust herbaceous layer with a lot of grasses, we didn't achieve that in our study. And I think that some sites might just not have that potential to get there. Or on our study, we might have had more frequent fire if we were able to burn every 2 or 3 years, and to somehow keep the woody sprouts at bay. Maybe some growing season burns. We could develop that, but it's maybe not going to be every site that can develop that layer. And then, as far as fire in the understory from those dry to mesic sites, we did see maybe a better response on the dry sites. The mesic sites, they weren't really harmed, but those where you've got things like trillium and wild geranium and all, they don't really need fire. So I think if it's possible from an operation sense to just kind of leave those areas alone, or maybe just try to not get the whole area black. I think that's a good way to maybe get more diversity too, is to to really hit the south-facing slopes, but just kind of let the north-facing slopes go. But fire at the same time didn't really harm those sites.